When I am given a radical expression, such as the square root of 25, and the number underneath the square root symbol, which is called the radicand, is a perfect square, I'm able to evaluate this expression. So what number times itself equals 25? The answer is just 5. 5 times 5 is 25, where I'm only giving the positive root because I was only asked for the positive root. If, however, the number underneath the square root symbol is not a perfect square, I'm going to simplify this expression. And a simplified version of this expression will not have any perfect square factors. So let's look at an example. The way that I'm going to simplify this radical is that I'm going to write the radicand, meaning the number under the square root symbol. I'm going to highlight this. This is the important part. As a product with at least one perfect square factor. So I'm looking at 50 and trying to think of a factor that is a perfect square. This one's a little bit straightforward. The perfect square factor of 50 is 25. So 50 is 25 times 2. Now I'm going to use this fact. The square root of 25 times 2 is the same as the square root of 25 times the square root of 2. As we already found, the square root of 25 is positive 5. And then since 2 is not a perfect square, I'm done. So the square root of 50, or radical 50, is simplified to 5 square root of 2, or 5 radical 2, because 2 does not have any perfect square factors, so this is fully simplified. And since there was no plus or minus here, I'm only being asked for the positive or the principal square root. Let's look at this one. Let's think. It's okay if I can't immediately identify the biggest perfect square factor. I just need to immediately identify at least one perfect square factor. So I can see that one perfect square factor of 1200 is 4. Maybe not the biggest one, but one of them. So 1200 is 4 times 300, and then I'm going to take the square root of 4 times the square root of 300. That means I can simplify this expression to 2 square root of 300. I am not done yet though. 300 has a pretty big perfect square factor that I can see. 300 is equal to 3 times 100. So I'm just going to keep going until that radicand, that number underneath the square root, does not have a perfect square factor. So I have 2 times the square root of 3 times the square root of 100. Now I could do this a little more efficiently. I could have written the 100 first, but I have 2 times the square root of 3 times what is the square root of 100? It is just 10. Now I need to go ahead and multiply the 2 and the 10, which gives me 20. And there's my final simplified expression, 20 radical 3, which is 20 times the square root of 3. Now maybe you can see now that I could have, or maybe you noticed earlier, I could have done this more quickly. I could have noticed, but I didn't, that 1200 can be written as the square root of 400 times 3, where 400 is just 20 times 20. And if you notice that right away, 400, oh my gosh, square root of 3, then I would have just in this number of steps found my same answer. But it's okay if you need to take multiple iterations. Just make sure you don't stop until the number underneath the radical has no perfect square factors. Next one, 10 radical 12. Maybe I should have done this one first. This is a little easier. 10 times 4 times 3, the square root of 4 times 3. So 4 is a perfect square factor. And I can realize that that's the same as 10 times the square root of 4 times the square root of 3. The square root of 4 is just 2. So 10 times 2 times radical 3 being the square root of 3. And now I am done. 10 times 2 is 20. 20 radical 3 is my simplified answer. Next one. I bet there's a perfect square that is bigger than the one I'm seeing, but I'm going to start with 4 again. So this has a coefficient of -1, and I'm going to do 48 as 4 times 12. So square root of 4 times the square root of 12. Square root of 4 is just 2. 2 times negative 1 is negative 2. Really common for students to stop right here and say, oh, I'm done. I'm not done because 12 has another perfect square factor. So now I'm going to rewrite 12 as, found it over here, 4 times 3. So negative 2 times the square root of 2, times the square root of 4 times the square root of 3, which is negative 2 times 2 times the square root of 3, or radical 3. That gives me my final answer, negative 4 radical 3, or negative 4 times the square root of 3. Maybe you can see right now the faster way I could have done this. We could have noticed that 48 was, and now I see it, 16 times 3. And that would have allowed me to do this faster. Square root of 16, square root of 3. The square root of 16 is 4. So negative 4 radical 3. So if you can, this is just like above, if you can identify the biggest possible square root factor, you can maybe do this in one step. But it's perfectly fine if you just keep going until you make sure that your radicand has no perfect square factors.